Hello and good afternoon, my dear kids. Welcome back once again to this short tutorial video for class 8 students under the topic factorization. Okay, since we are doing factorization, so in this video also we will continue with few sums with factorization. Okay, so this one we will be doing factorization of difference of two squares. Okay, factorization of difference of two squares. So for that you need to I will be using this identity, and you need to know this. Okay, since we have already used this identity as well in algebraic identities, so I think you might be familiar with this one, isn't it? A square minus b square will be equal to a plus b into a minus b. Okay, so difference of two squares. Okay, so how to approach for this kind of sums is, let's begin with the exercise. Okay, we have exercise 14e. Question number 1 we have here is x square minus 9, and remember, in this kind of sums, all the constant terms you will be getting perfect squares as your constant terms. Okay, so here we have first question, x square minus 9. So since we know that 9 is a perfect square of 3, isn't it? So for perfect squares, please we have what you can do is you can just revise from the topic squares and square roots also, because in the squares part we have done the squares of few numbers up to number, I guess up to number 20 we have done, isn't it? So we'll be using that as well. Okay, so in the first one what we have is x square minus 9. So we know that 9 is a perfect square of 3, isn't it? So we can write it as x square minus 3 square. See, now this one, it became in the form of a square minus b square, isn't it? Now the simple expansion was a plus b into a minus b. We have, in place of a we have here x, and in place of b we have 3, isn't it? So the simple expansion will be x plus 3 into x minus 3. So that is what we have we got in the product form. So we are done here, isn't it? Okay, so let's do a few more sums, it will be easier for you. Okay, so we have x square minus 4 in here. Again, 4 is a perfect square of 2, so we can write it as x square minus 2 square. Okay, so again a square minus b square. In place of a we have x, and in place of b we got 2, so it is x plus 2 into x minus 2. It's an easy one, isn't it? All you need to do is simply change the term into a square minus b square, and then you can use the identity a plus b into a minus b. Okay, there we will get the product form, and we are done with the factorization. So here we have, for question number 4, we have p square minus 1. We know that 1 is a perfect square of 1 itself, isn't it? We can write 1 as 1 square. So p square I have written, see, p square minus 1 square. Again a square minus b square form, a plus b into a minus b. Okay, now in this one, question number 5, yes, what we have here is we got 16a square minus 121. Now look at what did I said about previously. We need to know the perfect squares of numbers, isn't it? So what do I see here is 16 is a perfect square of 4. Similarly, 121 is a perfect square of 11. So it's 16a square. Remember, this square is just for a, not for 16. And minus 121 is a perfect square of 11. So that is what I have written. See, within bracket I got 4a whole square minus 11 square. So in place of a I have here, for this question I have 4a. In place of b I have 11. So 4a square minus b square. The expansion is simple, a plus b and a minus b. So 4a plus 11, 4a minus 11. Okay. Now similarly, in the question number 7 we have 36m square minus 169n square. Again the same rule applies. 36 is a perfect square of 6. So we have written here, for the first time I have written here 6m whole square. Minus 169 is perfect square of 13, so 13n whole square. I hope you are getting it, isn't it? So simple a. Now it came in the form of a square minus b square, so our expansion is simple, a plus b into a minus b. So 6m plus 13n into 6m minus 13n. Okay. And this one, question number 8, what we have is, and remember the identity was a square minus b square, isn't it? So in this one I have a question as minus 64 plus 25x squared. Now what do I see here is the constant terms, they are perfect squares. I know 64 is perfect square of 8. 8 times 8 into 8 is 64, isn't it? 25 is perfect square of 5. But I don't have the negative sign in the middle, isn't it? So simple, what you can do is you can simply arrange the question as well. See, if you write 25x square minus 64, it means the same thing, isn't it? I haven't changed anything, just the place of it, isn't it? See, 25x squared, the sign still is positive. The sign for 64 is negative, still negative, isn't it? Now this question, the 25 is a perfect square of 5, I know that. 5x, I have written it 5x whole square minus 64. For 64 I can write it as 8 square. See, why I have just switched the places of these two is because of, in order to use them in the identity a square minus b square. Remember the identity, it's a square minus b square. Okay, so 5x square we have here and minus 8 square. So now it's in the form of a square minus b square, so a plus b into a minus b. Okay. Yes, now this one, question number 9 we have here is x square y square minus a square. So again the same thing, x square y square, this can be written as xy whole square. See, we are using the identities of exponents as well, a to the power m into b to the power m. The exponents are same. What you can write? You can write a into b whole to the power m, isn't it? See, everything, every topic, there's a concept for every basics, isn't it? Every topics. So that is why the basics were important, as well as the topics that we have done previously were important. Okay, here you can simply use the first of all you can use the identity of laws of exponent, then proceed with the identity. So xy whole square minus a square, again a square minus b square. In place of a I have xy, in place of b I got a, so x plus y plus a, x plus y minus a. Okay, and in question number 10, yes, question number 10, what we have is x to the power 4 minus 9. Now see, x to the power 4, it can be x square whole square, isn't it? Again, one of the identities. See, one of the laws of exponents, a to the power m to the power n. If you write x square into x square, it will be x to the power 4, isn't it? So that is why I have done here. See, for x to the power 4, I have written x square whole square minus 9, as you know, is a perfect square of 3, so 3 square. So a square minus b square. Again, for in place of a, I have got x square, so x square plus 3, x square minus 3. Now see, here in this one you cannot again use the identity, because sometimes you may get questions like where you have to use again the identity. Okay, x square minus b square will be in the form. So here, but we cannot use out here. Why so? Is because x square minus 3, and 3 is not a perfect square, isn't it? So we have to stop here. Okay, if this would have been 4, if this number would have been 4, then again we would need to use identity a square minus b square, because as we know 4 is a perfect square. Then again expand the term. Okay, don't worry, we'll get that sort of question as well. Okay, so a to the power 8 minus 36. Now 36 constant term, perfect square, 6 square, we know that. A to the power 8 can be written as a to the power 4 whole square, isn't it? So see, a to the power 4 whole square minus 6 square. So, and remember, you can use the law of exponent as well out here to check your answer whether it's correct or not. A to the power 4 to the power m, for 2 exponents, 2 powers, what do? We multiply the powers, isn't it? 4 into 2 is 8. So that is why it hasn't changed. Then we haven't changed the value, isn't it? It's still same. It's just that we have written it in the form of 2 exponents. So we have here a square minus b square, so a plus b, a minus b, and we are done here. Okay, the next question I have chosen is from question number 13. So I have here 1 minus 4c to the power 12. Now I know 1 is square of 1. For 4, a constant term is a square of 2. For c to the power 12, can I write it as c to the power 6 to the power 2? See, if I write c to the power 6 to the power 2, now see, why have we used the bracket in here is because this square is applicable for both the terms inside the bracket, isn't it? If you square 2, you will get 4. See, 4. And c to the power 6, 6 into 2 is 12, c to the power 12. See, in this way also you can cross check whether you have the form that you have written in is correct or not. Okay, so 2 to the power 2 into c to the power 6 whole square will give you 4 c to the power 12. That means it's correct. So we have in the form of a square minus b square. In place of a I got 1, in place of b I got 2c to the power 6. So a plus b, a minus b. What that is? 1 plus 2 c to the power 6, 1 minus 2c to the power 6. Okay. Okay. Now I have chosen for the decimal form as well. See, because few questions you may get in decimal form as well. See, question 15 we have 2.25 a square minus b square. Now what I know is 2.25 is a perfect square of 1.5. 1.5 a again a square. This square holds for this just for a, so 1.5 a whole square. I hope you got this one. 1.5 a whole square. This square is now applicable for both the terms, so that is why 1.5 square means 2.25 and a square minus b square. So in place of a I have got 1.5a, in place of b I have b, so a plus b, a minus b, that is 1.5a plus b, 1.5a minus b, isn't it? Okay. Okay, now for this one, I have chosen one fractional form as well. I've got one term in the fractions. So see, what I have is 25p square. Now I know 25 is a constant term. It's a perfect square of 5, so I can write it as 5p whole square, isn't it? Minus, for 1 by 9, can I write it as 1 by 3 whole square? See, 1 by 3 whole square, that is 1 by 3 into 1 by 3, the numerator will get multiplied. 1 square means 1, see, 3 square means 3, 1 is in numerator, 3 is in denominator. Okay, so this is how we got the question in the form of a square minus b square. After that, it's simple, isn't it? A plus b into a minus b. Okay. Okay, let's do a few more sums and we will be done. Okay. Okay. For question number 18, what do I have is, see, we got 16a square divided by 25b square minus x square divided by 100y square. Now all the constant, look at the focus at the constant terms first. 16 is a perfect square of 4, so it can be written as 4a square, a whole square, isn't it? 25b square can be written as 5b whole square. Now, since it is in the fractional form, so I can just directly write it as whole square, isn't it? Again, here you may say that we have followed one identity as well. That is laws of exponent. That is a to the power m divided by b to the power m. What you can write? You can write a by b whole to the power m, isn't it? So that's what we have done here. See, 4a by 5b whole square minus, see, now here we have the second term, the numerator we have x square, so it will be simple x, isn't it? Now 100 we know it's a constant term, a perfect square, and it's square of 10, so 10y. See, again I have written x divided 10y whole square, so we have it in the form of a square minus b square. And what did I say? If you are confused with the term, that is whether you have done correctly or not with a square minus b square, the term, you can cross check it. Okay, so how to cross check it? The square belongs to all the terms inside the bracket, so 4 square is 16, a is square in the numerator, in the denominator see 5 square is 25, b square, so b square. See, again the second term in the numerator x square, 10 square is 100, y square, see. Okay, now since we have got in the form of a square minus b square, so it's simple one again, a plus b into a minus b. Okay. Okay, number 19 we have here again is minus 36 plus 1 by 49 m square. Now what we have done in previous sum as well, one similar question to this one, isn't it? So I have switched the places. See, 1 by 49 m square minus 36. So I know the constant terms, they are perfect squares. See, 49 is perfect square of 7, 36 is perfect square of 6. So simply I can write it as m by 7 whole square, because this 1 into m square, they will get multiplied, isn't it? Numerator into numerator, so I can just simply write it as m by 7 whole square. Again, if you want to cross check, m square, 7 square is 49, it's in denominators, you see, minus 6 square, 36 6 square. Now it's in the form of a square minus b square, so simple, a plus b into a minus b. Okay. Okay, yeah, we got for constant terms as well. See, we need to find the value of the question was given to find the value of for certain without actually squaring or something like that. Okay. Okay, since the question I have just directly written the question out here. So okay, question number 21, what we have is 100.6 square minus 99.4 square. If you go in with multiplying with that 100.6 into 100.7, it will be a bit lengthy, isn't it? So this is where we use identity. See, in order to simplify our sum as well. So we know that it's already in the form of a square minus b square, so why to square it? what we know is we can expand it in the form of a plus b into a minus b. So that's what I have done here. See, a plus b into a minus b. Now after adding 100.6 and 99.4, what I got is 200. Bracket means multiplication, I know, we know that. So into 100.6 minus 99.4 is 1.2, so 1.2. Now 200 into 1.2 will give us 240. So there's how we got the value. See, it's easy one, isn't it? Instead of going with all the squares and all, then subtracting, it's a bit easy, isn't it? Okay. Okay, then the final sum for today we have here is for question number 22. What we have is 4.987 into 4.987 minus 3.013 into 3.013 divided by 4.987 minus 3.013. Now see, 4.987, I can write it as 4.987 whole square, isn't it? Minus 3.013 into 3.013, I can write it as 3.013 whole square. The numerator I have got in the form a square minus b square, and the denominator I have already have 4.987 minus 3. See, in this sums there will be relation among the terms. Okay, so what do I see is we saw the same terms, isn't it? Remember, we cannot cancel these terms directly because of this negative sign. Remember that. Okay, because most of the kids do their mistake. That is the point where they mistake. You cannot cancel the term directly, remember, because we have the negative sign out here. Okay, then for this one we can write it as a plus b into a minus b. So that's what I have written, a plus b into a minus b. Now see, simple, this minus term 4.987 and this minus term, we can cancel these two terms, isn't it? Numerator, denominator, now we can cancel it. This entire, because of the entire term, remember, because of the entire term. Okay, now what we are left with? We are left with 4.987 plus 3.013. So 4.97 plus 3.013, and after adding I got answer as 8.000. So I can simply write it as 8, isn't it? Okay, so I hope you kids have understood this lesson from the video. And yeah, the remaining sums are similar sums. Okay, I have picked all the variations from this exercise, and what I want you to do is I want you to please do the remaining sums. Okay, and if there comes any doubt, then you can contact me anytime. Okay, so till then, stay safe and stay tuned in for more videos and more updates. Okay, bye bye.